All right, I want to thank everyone for joining us this morning or this afternoon, depending on where you are. My name is Andrew Sauterelli. I'm one of the technical support specialists here at Autodesk for Simulation Mechanical, joining you from lovely, rainy Munich, Germany. And with me today is Sualp Ozel, the product manager for Simulation Mechanical. And today we're going to be talking about how to better utilize the Nastran solvers within Simulation Mechanical. So just to give a little bit of background on this presentation. We do webinars monthly talking about various topics within Simulation Mechanical to better help you utilize the software, and it's typically done by the technical support team. And thankfully today I'm joined by Sualp to talk a little bit more about how to get some better use out of those Nastran solvers that got added over the past year. So at this point, I'm going to turn it over to Sualp, and he'll talk to you a little bit more about Nastran.
Hi, everybody. So I guess I shall show my screen and go from the beginning. Can you guys see my screen? And hopefully that's a yes.
Looks good.
All right, excellent. So today I wanted to talk a little bit about the background of what we did in the past year or two about adding Nastran solvers into Simulation Mechanical. So I'll do a little bit of repeat information for those of you who have been keeping up with the latest and greatest from SimMech. But after that, we will go into basically live demo mode. I will open up a single part file, mesh it, and set it up in linear static stress, and create a multi-load case setup. And then I'll do a quick simulation and post-processing using Simulation Mechanical solvers, and touch on the tip of the day for our post-processing. So hopefully this will be something new for everybody. And then I will highlight exporting our setup to the Nastran editor that is included with Simulation Mechanical, and talk a little bit about what the Nastran file looks like. And I will highlight the predefined load sets that we have created using multiple load cases, and I will explore some of the deck structure, and I'll touch on editing the deck, changing the magnitude and direction of certain loads in different load cases, and having full control over that using the Nastran deck. And I will simulate it directly within the Nastran editor, and take those results back into Simulation Mechanical, and we'll touch on reporting a little bit. And then finally, if you have some time, we'll get into editing additional deck content, such as contact types and parameters. So let's get started. And I only have 2 slides for touching on the things that we have done in the past 2 releases. So the first one is the availability of Nastran solvers within Simulation Mechanical. If you set up an analysis using one of these 6 analysis types, so that's linear static stress, nonlinear static stress, modal with load stiffening, critical buckling, and steady state thermal, if you are running one of these 6 analysis types on a day-to-day basis, you can choose to run your setup with a Simulation Mechanical legacy solver, or you can choose to run it with an Nastran solver. Of course, if you are choosing SimMech solvers, you have a couple of options for the solver type. You can be using a sparse solver or an AMG solver, and so on and so forth, and you have controls over the type of solver you want from SimMech directly within the interface. For Nastran, you have similar options as well, but those controls are not necessarily in the user interface. So that's the type of information we'll be touching on today, is how to control what you can do with the solver, and how to even control the setup of the analysis. And you can do a run within Simulation Mechanical one of 2 ways. You can just go to the ribbon and go to the Analysis tab, and in the 2015 re-release, so that was around July, August timeframe, so the 2015 R1, as we called it, is an option that lets you press on the bottom half of the Run Simulation button, and then you get the option of choosing a Simulation Mechanical solver or a Nastran solver. Alternatively, if you go to the Solver Manager, it brings up a dialog, and if you have multiple design scenarios, you can choose the design scenarios that you want to analyze, and then you can choose whether you want the Simulation Mechanical solvers or the Nastran solvers directly, and when you hit Analyze, it will go into the Job Manager and start solving using one of those two solvers. So this is the way that you would interact with the solver within the Simulation Mechanical interface. And hopefully you guys have seen or used some of that information. So the other workflow, which is the workflow I'll be highlighting today, is the ability to export your setup to the Nastran editor. So this is in the application menu icon on the top left, the big S. From within the FEA editor, if you click that big S, you can go to the export dropdown and export it to one of many different formats, and one of those new formats we added in the 2015 re-release, which is also included in the 2016 release, is the Nastran editor. I see some messages popping up. Oh, that's just Andrew. Okay. So that's the information we're going to be touching on.
So I will...
Go ahead.
So we'll launch a few poll questions here just to see how familiar everyone is with Nastran.
That's great. Let me finish this slide and then I'll pause for all the questions, if that's okay. So here, in the export workflow, you can export the setup of all those same analysis types, the first 6. So linear, nonlinear, modal with load stiffening, critical buckling, steady state. Plus, you can export a 7th analysis type, the dynamic design analysis method, which is basically the American naval shock testing analysis type. So you can export that type of an analysis setup into the Nastran editor to be able to use the Nastran editor to do editing or solving directly. And then when you solve your analysis using the Nastran solver, you can merge your results back into simulation as well. And we'll demonstrate all of these in our demo. So I'll pause here and have Andrew go through some of the poll questions.
All right, thanks. So our first one is, what is your familiarity with Nastran? Is this your first kind of exposure to it with Simulation Mechanical? Maybe you've used it before in the past. Maybe you're actively using it now within Simulation Mechanical. So go ahead and give us your feedback here. Looks like we got most people, about 80% at this point, saying they've never used it before. So I'm going to go ahead and close these polls, and I'll just share the results with everyone. So we've got about 75% have never used it before. 10% of you have used it, but you're not currently using it, and 15% of you are using it for some simulations right now. So we do have another related one, and we'll launch that. And simply, what is your go-to solver for Simulation Mechanical at this point with 2016? You've got the option for both Nastran and SimMech. Which one do you prefer? So it looks like the large majority here are saying SimMech solver. Give everyone another 5 or 6 seconds here. And we'll share that. So it looks like 94% of you prefer the Simulation Mechanical solver to the Nastran solver currently. So it's a pretty good margin there. And Sualp, we'll let you continue your demonstration. I'll interrupt a little bit later with some more polls.
Okay, perfect. So let's get going with our. Let me know if you can see my screen, by the way.
Good.
Okay, so I will start with our demonstration. So our first demonstration will set up a basic static stress so that we can play with the Nastran deck. So let's go ahead and do that. I have Simulation Mechanical. Well, looks like I had it open already, so we'll let it come up. Okay, so I now have 2 of them. Let me close one of them. So I'll bring this one over here, close the duplicate, and I will put it to the side. I'll bring my webinar folder and I'll bring it to that side. So I have my Simulation Mechanical interface and I have my folder over here. So we'll keep a close eye on what's happening in the folder structure. So I have a step file. So this is the first tip of the day for those of you that have been using it for a long time, or maybe for those of you that are kind of new to Simulation Mechanical. When you launch Simulation Mechanical, this is the interface that comes up that lets you open a file or create a new one or look at your recent files. If you cancel out of this, you can simply drag and drop files into Simulation Mechanical interface. So this is tip number 1 for the day. And it automatically creates the finite element model file, which is the main file that we deal with. And then it creates a design scenario data file. So design scenario data file is created because we have a single design scenario, and in it you will see design scenario 1. So if I were to right-click and copy this, for example, and create a design scenario 2, you will see that folder number 2 gets created. And in these folders are important information about things like materials and mesh and stuff like that. So just a little bit of a background on the file structure for Simulation Mechanical. We have a single FEM file, but then we also have a folder that contains information for each design scenario. All right, so let's get going. I'll go back to design scenario 1 and delete my second design scenario because we don't need it right now. No, we'll keep it. All right, so the first thing we want to do is create a mesh. Now I'll go ahead and generate a 3D mesh using the default settings. I'm not really too interested in the mesh quality or the mesh results at this point. I just kind of want to create it so we can demonstrate the Nastran capabilities. All right, so we have our mesh. Second tip of the day is color by. I use this all the time. It is under View, Appearance, Color by. I can make every surface a unique color, and I can turn off the CAD surfaces to see my model in a different visualization. So this is kind of easier for me to look at my models when I'm adding loads and boundary conditions. So once again, that was under View, Appearance, Color by. So I've changed it to unique colors per surface, and I've changed it so that I don't look at the original CAD surfaces, I'm just looking at the meshed geometry. Okay, so next, let's just add some loads and boundary conditions. So I'll say that surface, that surface, that surface, and that surface. So those 4 bolt hole surfaces, let's say, have a fixed boundary condition. Okay, so now, if I rotate, you'll see those fixed boundary conditions in design scenario 1. They are right here. Okay, now we have to add a load to this. And the load that I want to highlight in this demonstration is gravity. So I go to the gravity load, I turn it on, and let's say -z is good enough for me. And then I come into the multipliers tab and add 2 rows. So let's call this 1G, and let's call this 1G as well. It's just a duplicate. And let's call that, let's turn on the multipliers for gravity for both load cases. So they have the exact same load definition. If I hit OK and run this analysis, I'll get 2 different load cases, and they will both have the same results. They will both have the same load and same boundary condition for the same mesh and the same material. The reason why I wanted to highlight this is basically I wanted to highlight one of the limitations within Simulation Mechanical. In Simulation Mechanical, you can control within static stress the multipliers for gravity for different load cases. So you can make it such that it's 2Gs or 5Gs, right? So you can control the multiplier between different load cases, but you cannot control the direction, X, Y, or Z direction for a given load case. Okay? So this is something I wanted to highlight. So let's go ahead and do a quick test. 1G, 5G in 2 load cases, and they both have the same -z direction. So let's just change it to -y to be a little more, well, -z is fine. Why not? Doesn't really matter. All right, so let's go ahead and run this analysis. Of course, I have to give it a material. It was a step file. It didn't have a material. So let's just go A36. And now we can run this analysis. I'll run it with Simulation Mechanical just so that we can get the results. And it's running through the job manager here on my end. And it's meshing right now, and it's running. And the meshing phase is to create the internal solid mesh elements for those of you who are interested. And as you can see, the Design Scenario 2 folder is almost empty because I haven't done anything to it. But the Design Scenario 1 folder got populated with a lot of different files. Right? These include things like the log files, the PNG, some of our displacement outputs, as well as some of our reaction outputs, as well as our stress outputs. So all these files are here. So I've got my results in here as well as my mesh information. So we're looking at our results. So let me make my legend a little bit bigger so everybody can see it. So I'm going to make my fonts a little bit larger. Let's go make it 12. Sure, and let's make it 5 precision. That's good enough for now. Here we go. So we have 2 load cases, load case 1 and load case 2 is not shown right now. We're looking at first one. And we have a displacement of 1.7 e to the minus 5. So let's do a quick calculation. 1.769, right? Let's forget the e to the minus 5 for now, times 5. My second load case should give me roughly 8.8 as the maximum displacement. So let's go to the next one, and as you can see, we have the 8.845. So it's a straight multiplication of the load, which means this maximum displacement will be a straight multiplication as well. So this is all great. All the results are coming out as we expected them to come out. And our G is in the minus Z direction, as you can see, in both load cases. Okay, so we haven't really touched on anything new so far. So here comes our tip of the day from our PowerPoint. We looked at creating a multi-load case, we simulated it, we post-processed it, and here's our tip of the day. So if we are looking at, let's say we're looking at stress results, and these numbers are kind of small to begin with, but let's say we are interested in selecting some points, some nodes. If I select all of them, it selects quite a few nodes. But what if I wanted to select and inquire a subset of all of these nodes, such that I wanted to maybe select some of the high stress points? Let's say I wanted to have a threshold of 0.4 newtons per millimeter square as my threshold. So in Simulation Mechanical, we have something called a filter. It's down here in the tree, in the results environment. And you can right-click and say, I want to add a selection filter to the current results. And when you do, you can say, I want to have a filter where my minimum value is 0.4, and you hit OK, and it adds a minimum filter of 0.4 or greater. Now, when I do the same action of rectangle select, it only selects those nodes that are that have stress values of 0.4 or higher. So when I inquire them, you will see that the values that it's picking will be within that filter. Now, this filter, of course, works for unsmooth results. So we kind of have to go into the unsmooth version of our results, and you will see a better, display of that. Right? So all these nodes, so this one, for example, let's pick this one by itself. When I right-click and inquire, you will see a couple of numbers that is less than 0.4, but then there's a couple of them that are greater than 0.4. So that's the results are, result filtering is based on unsmooth results. So that's something to remember. And for those of you who are not familiar with smoothing, right, let's go ahead and show you the mesh results. So we have a couple of elements that participate in that node. Now let's pick a much easier one to show. So if I were to get rid of this filter quickly, and maybe pick that point right there, maybe this one will be a little bit easier to see. There we go. That node is shared between 4 elements. Okay, so if I inquire that, you will see that that's element 1, element 2, element 3, element 4. Well, it looks like there's a couple more on the inside as well. And they all have different values. And the smoothing takes the average of those values. So that's what I was referring to with smoothing. So to reiterate, our tip of the day for post-processing is if you want to be able to select a subset of the nodes and you want to add a filter, you can do so by adding a filter to your current selection, giving it a minimum or a maximum value, and when that filter gets added to the list, your selections will now include those items. All right, let's go back to our presentation and continue with exporting this to Nastran Editor. So let's go back and say that we want to export this. So what I did is I went back to from results environment, I went back to the FE editor. Now I can go and export this to the Nastran editor. And of course I have to give it a location. It popped up on my other screen, so let's go ahead and select the desktop and call it the webinar. So I will put it in my webinar folder. I'll give it a new folder name. So I'll put everything in here. And let's just call it DS1. So this is my design scenario 1, creating DS1, hit save, and that creates in the Nastran folder a file that is called LDD. This is kind of like our log file, and it creates, and I'll put this over here again, it creates the .nas file. And that .nas file automatically gets populated in the Autodesk Nastran editor. And as you can see, if you look at this again, you will remember this was our geometry in Simulation Mechanical, and then the same geometry in basically text format shows up in the Nastran editor. And if you wanted to make sure you understand what this thing looks like, you can go to the model/results, and you can kind of see it in here in 3D as well. So it does have a built-in kind of like a post-processor, but this will look very foreign to you if you've never used Editor. I just want to mention that if you wanted to take a look at it, it's available. You can turn on the mesh edges, so you can see that same mesh in the editor as well. So to do that, I right-clicked and I said Element Edges. Okay, so right now, this is only the setup. It doesn't have the results. And if I want to run it to check and see if the results kind of match with Simulation Mechanical, I can simply go to Analysis and Run. The one thing that I'll highlight here is contact. So this is a single part object that doesn't necessarily have any contact defined. In the setup, we said we don't have any contact. Our default contact is bonded, but it's a single part, so it's not contacting anything. In Nastran, there's a detection tool for contact between parts, and it is written to the Nastran deck from Simulation Mechanical as one of the top lines. So this line right here, the contact generates, detects contact between parts. But of course, if there are no parts to define contact, it will fail to define it, and it may end up giving you an error message. And we have a little comment here that talks about this. So if I run it now, it will give me an error message. So if you have a single part, I recommend just putting a $sign, which converts a text line item into a comment line item, kind of like every other green item that you see here. And now you can run it without any error messages. All right, so I just hit run, and it's running. It takes a little bit of time, and as you can see, Nastran solvers populate multiple files as well. And it's calculating all the stresses and deformations just like the SimMech solvers are doing. And now it finished results for subcase 1. It moved on to subcase 2. And it finished. So let's say I want to load the FNO file and go into the results. And now, if I rotate my model, I can change directly in here to look at which load case I want. Let's say I want to look at the load case 1. let's say I want to look at the displacement total translation, I can right-click and say contour, and it gives me the similar numbers that I received with the SimMech solvers, 1.77 if you remember. Let's go back and double check what the results were for the load case 1. 1.77 e to the minus 5, 1.77 e to the minus 5. So as you can see, both solvers populate similar results for a similar run. Now this webinar is around the benefits of using Nastran over Simulation Mechanical, and now that we understand how Nastran works, let's get into the benefits of it. Okay, to do that, I have to explain what the Nastran deck looks like a little bit. So the Nastran deck is a combination of our loads, our boundary conditions, our mesh, and material information. So the first thing we talked a little bit about is contact. And then the next thing that we have that we can see here is the load cases. We have subcases 1 and subcases 2. And then we have all the elements. So these are all the brick elements written in the Nastran deck. If I scroll all the way down, I can see some of the pyramid elements, for example, tetrahedral elements. All those elements get written into the deck. Then these are, after that, we have our grid points. So these are all the nodes. And then if I scroll down, and this is all alphabetic, by the way. After my grid points are done, I have my load cases. I have the different definitions of load cases, different definitions of materials, and some parameters. And then finally, my parts. So I have a single solid object, some of my rotational angular velocity and angular acceleration, as well as my boundary conditions. So that's what this whole file looks like. Okay? And then if I have some temperature loads, that they show up here as well. So it's really nothing that complicated. It's just a big list of things. And if I were to collapse each group, it would be like 5 or 6 groups of information in a text file. And because it's a text file, I can edit it. Before I get into editing, are there any questions? I'm going a little fast here. Just want to pause for a second, and if there are any questions, I want to answer them. Andrew, anything?
So yeah, we did have a couple questions here. I think we're starting to get to the point where we're answering them. So Aaron asked, what are the benefits of using the Nastran solver? And sure. I think we're just about to get to that. That's right. And then Steve, please discuss why I would choose the Nastran solver sure. over the Simulation Mechanical solver. Yep. So I think we're going to get to that in a few minutes. And then right. Gonzalo, also, when do you use Nastran? So if everyone just bears with us for another couple minutes here, I think Sualp's going to really highlight some of the key points of why you're going to use Nastran.
Perfect. Thank you. Yeah, no, good questions, guys, but I just wanted to make sure that everybody's on the same page with some of the basics of how to get to this point. And now that we're in here, let's go into this next slide. So in this slide, let's show it like this. When we export a Simulation Mechanical file to Nastran, we populate the Nastran deck with a predefined load set IDs. So we have a list here, and this deck will be available. You can look at it later, but I just wanted to highlight some of these numbers and what they are referring to. So we have 2 different physics. We have the structural physics that we export, and we have the thermal physics that we export to Nastran. And for example, the gravity load from the structural side gets exported to Nastran as a set ID of 99,998. And what this is referring to is this gravity load. And we have the same thing as the pressure multipliers down here. We have the displacement multipliers, which is over here. We have the thermal multipliers over here. Voltage multipliers, and this is an asterisk because Nastran doesn't have electrostatics. This is just a placeholder. If or when we have Nastran solving electrostatic, we can export those as well. Same thing with our angular velocity and angular acceleration for omega and alpha, and similar items for thermal loads as well. So now that we've established these numbers, let's take a look at where they show up in the Nastran and how we can edit them. Okay, so that was quadruple 9 and an 8. But more importantly, it was for gravity. So let's search for the word gravity. So what I'll do is I will do a Control F, and search for gravity. And I'm going in the down direction, and I hit Find Next. And this is the point in which the gravity load that I have defined got added to the system. And as you can see, it says gravity was exported from Simulation Mechanical as quadruple 9.8, and this is the value, and the rest are the X, Y, and Z multipliers. So it gets kind of tough to read this, so I hit Enter, and I'm going to go and edit this deck and add a narrow or a wide field helper. So this format of the gravity card, and everything that you see in blue here is a card, is a narrow. And I've added the helper, so it shows me the section up to 10 sections on that card. And I'll add one more thing for myself. I'll add a marker, field marker, narrow, so it shows me everything in columns. So you can think of it as Excel columns, essentially. So this is column 1, 2, 3, 4, 5, 6, 7. And you know, this is not written in English, right? And to understand it better, I need to understand what each column is referring to. So I can come over the gravity card and hit F1 to read more about it. F1 automatically takes me into the help section where the gravity card is defined. So the gravity vector, so this is the card and what it looks like, and these are the different sections within each card. So as you can see, this is just an ID. 99998 is just an ID. The number 4, which is the G, gets defined here, is the gravity vector scale factor, and then there's the N1, N2, N3, which are the components. Okay, so that means if I understand what this card is and how it's authored, I can change it. So I will have, let's say I wanted to add a gravity in Simulation Mechanical in 2 different load cases, not only in 2 different magnitudes, but also in 2 different directions, right? So if I wanted to have 1G in minus Z in load case 1, but 5G in minus X in load case 2, I can do that in Nastran. I can't do it in Simulation Mechanical in a single design scenario. So that's the benefit. So let's go ahead and do that, right? I'm going to copy this line, hit Enter, and paste it. So instead of the 9998, I'll give it a new number and just call it 9990. And I'm picking a number that is different than one of these pre-populated ones, just to avoid any mistakes I may make. So I try to avoid these numbers when I give it a new number. And this is why I wanted to highlight these existing numbers. So we have a new gravity, and this time I wanted that new gravity to be, let's say, 0 in the Z direction, but plus 5 in the X direction. So I just changed not only the direction, but the multiplier as well in a different system. To make things simpler, I'll just put it in the X direction as a plus X. Okay? So now I have 2 gravity multipliers. I'm sorry, I have 2 gravities defined. I just have to add them into the load definition. So let's go and find that area of the code where my loads are defined. So as you can see, the load combinations are defined down here. So I have 2 load cases. That's the first one and that's the second one. Okay, and let's read about that by pressing F1. And we can find out the ID for that load set and everything else. Let's find out where gravity is defined. And I know for a fact the original gravity was the 9998, and it was down here. And it was the same in both of them with a multiplier of 5. So I can just change this 8 to a 0, and I can keep the multiplier as 5 if I want to, of course. And I have changed the direction to X. So now I have done all the changes I needed to do to this Nastran deck. So when I run this analysis, and it's running it's going to take a little bit of time. I will have 2 load cases. the first load case with a minus Z 1G load, and the second load case will be a plus X 5G load. All right, so it took me, a couple minutes with explanation as to what I'm doing to set this up. And I only run it once, and I have the results. And I'm not really that good at looking at results in the Nastran editor. So what I'll do is I'll go back to Simulation Mechanical, go back to FE Editor, I'll go into here, and instead of exporting, this time I'll do a merge. And when I do merge and find my webinar folder, my Nastran folder, I change my file type to a Nastran result, and I have the FNO file that I can merge in. So that FNO file is the result file for a Nastran run, and it's over here. So when I hit open, it takes a second or so, and it successfully merges those results back in. And when I go into the results environment, now I have, once again, the results that I get from Nastran for minus Z 1G load. And now I have results that I get from Nastran for a 5G load in the plus X. Now, the mini axis doesn't reflect that, right? Because the setup we did in Simulation Mechanical is what it's relying on to show the mini axis for the gravity loading. So you kind of have to ignore this, right? Because you've gone advanced in this case. You've added your 5G load in the X, and you can see that because this was the undisplaced shape and this is the displaced shape, and clearly the load is pushing it in the X direction, right, as a 5G. Now the numbers are not going to be a straight 5 times multiplication because you've changed the direction, right? It will be a totally different number. And you were able to solve this analysis within a single design scenario using 2 load cases with totally different loads, and those loads you couldn't have set up in Simulation Mechanical. I'll pause for a second and see if there are any questions with the setup.
It doesn't look like we have any questions right now, Sualp, on the setup here. But if anyone does, feel free to post those in the question window.
So we have just finished exporting to the Nastran editor, simulating it, post-processing it. Now let's get into the reporting tip of the day. The reporting tip of the day for an analysis that you do using these techniques relies on the user, right? So if you go into the report, because you have really customized load case 2, your load case information for load case 2 will not be properly populated. So this says 5G, which in our case is true, but the direction for load case 2 is not minus Z. So when you export this to Word, you kind of have to remember to add a new table here and create your second load case gravity acceleration to be a positive X for load case 2. So you have to customize your report to better fit your intentions, right? When we created Simulation Mechanical years ago, we didn't have Nastran integration, and we didn't have the ability to merge in a Nastran solved result that you have customized the Nastran deck for. So our reporting doesn't really know what you did in the Nastran editor to customize the text. So therefore, your reports are going to be out of sync with whatever text editing you've done with the Nastran editor. So be very careful whenever you do an edit like this to save on solve time. And I will explain what I mean by save on solve time. You will get a out of sync reporting. Okay, so you have to be careful with reporting. All right, so let's explain what I mean save solve time. So imagine, wrong button. Imagine you have an analysis where you have hundreds of parts, and you've meshed it, and you have a couple million elements, and you have a really large part. And in fact, this part kind of represents the complexity of the part that I'm referring to. This is an airplane GE engine bracket, and it's very common in the aerospace industry to be able to solve parts or assemblies using different load cases and different gravity directions. So it's almost a common requirement for them to be able to have, to accommodate takeoff conditions and landing conditions, and for the same part. And to do that, they often need not only the change in G load, but also change in direction, because obviously the loading changes based on takeoff and landing. So in cases like that, you don't want to solve in two different. I mean, you can definitely set this up in Simulation Mechanical using two different design scenarios. So let's go ahead and explain what I mean by that. You can solve it in a single load case for the first design scenario. So let's go ahead and delete that one. Hit OK, and you can just rename this. This is 1G in minus Z. You can call that, and then you can copy this. You can call this 5G in plus X, and then when you get in here, you change the direction to 0, 1, 5. You can do all of this, and now your ribbon your mini axis kind of goes ahead with your setup, and you can use the solver manager and solve both of these simultaneously or in sequence. You can solve this, and you would get the same results. But you can imagine that if solving a single design scenario takes 2 hours, solving two will take 4 hours, right? And if you solve them simultaneously, it might actually take 5 hours, for example, because simultaneous solves take extra resources. But long story short, instead of solving this in 5 hours, or if you have multiple versions of this, solving it in 10 hours, 20 hours, however many hours, you can just set up all of them in a single single design scenario with multiple load cases and solve it in one shot using the Nastran in fraction of the time. So it's a big time saving for those things that you can't do in Simulation Mechanical in a single design scenario. You can do that in Nastran with a single design scenario by using these combinations of load cases for different loads. So that is the time saving that I'm referring to. So the next thing I want to highlight, and I'll load this up, is contact. So we are able to talk a little bit about contacts and parameters. So let's go ahead and talk about that. And I'll go ahead and delete load case 2. I'm sorry, design scenario 2, and we'll talk about that single part. So to talk about contact, we obviously need an assembly with multiple parts, and I'll just continue using this geometry. I like this geometry, and I'll just add another part into it. And I'll export this using the Tools, Edit, SimStudio Tools option. I'll export this geometry to SimStudio Tools. So if I push this to the side again and get into my webinar, you're going to see if I save this, let's call it bracket V2 SimStudio, it creates a bracket V2 SimStudio file for me in that same folder. And right now we have a single body, right? And I will create a new component from that body. So now I have a single component, and we'll call that bracket. And I'll create a new component so I can have contact between those two components. And to do that, I like to get into the sketch mode, create a sketch on that surface, and I'm not really interested in dimensions or anything. I just want to create a rectangle. Let's say that rectangle right there, and right-click and OK. So I have my sketch, and what I will do is I will pick those two profiles, right-click and say press and pull, and make a new component out of that geometry. So when I do, I have my original bracket geometry up top, and I have my, let's say, base. So let's go ahead and rename this guy, call it base, I have my base part. Okay? All good so far. When I save this, I have this assembly of 2 parts, and I can push this into Simulation Mechanical. And in fact, it started to show up on my other screen, so I'll go ahead and merge it over here. So I have this 2-part assembly, right? And to talk about contact, especially in the case of Nastran, Nastran can handle contact regardless of whether you have a matched mesh or an unmatched mesh. In one of my previous webinars, I talked about how to create an unmatched mesh using Simulation Mechanical 2016. It's going to be even better in 2017, so I won't really highlight those functionalities yet. I'll go ahead and do the actions to create the unmatched mesh in 2016. So to do that, it's a couple steps. The first one is to enable the smart bonding. The second one is to call it surface contact, for example. And the third one is creating the mesh using without imprinting. So we've done all those 3 steps, and this should create, if I remember correctly, the unmatched mesh and between the parts. So it looks like it almost still created the unmatched mesh. So let's go ahead and do free and see if that helps us. That's probably better. I don't see that matched looking mesh. And one way of looking at it would be to take a look at this and say isolate and see if the match meshes between those 2. So let's go ahead and look at the match. And it is currently an unmatched mesh between that surface and that surface. So that's good. That's kind of what I wanted to see. So I wanted to create an unmatched mesh. All right, so let's go ahead and show everything by using the view show all surfaces, right? And let's add some dummy loads and boundary conditions. So I'll add a surface general constraint of fixed, and then I'll add maybe a bearing load of 10 newtons in the z direction. Okay. So before I get into the benefits of Nastran, I first have to export this to Nastran, and but I can still talk a little bit about it. So in the case of unmatched meshes with things like surface contact or any other contact type really, Simulation Mechanical cannot solve these types of analyses in static stress analysis. The unmatched mesh and contact only work for a small subset of contact types, namely bonded and welded within static stress, if you have enabled smart bonding, right? Bonded, welded works. But if you were doing surface contact, for example, it doesn't work. We don't have a smart bonding setting for surface. And in complex assemblies, it's easier to create an unmatched mesh. And if you can only create an unmatched mesh, or the quality of the mesh you're creating with matched mesh is really bad for static stress, and you need surface contact, you're better off just sending this to Nastran. So let's go ahead and export this, and let's add some more boundary conditions to stabilize the system. So let's say that I want to add a surface general constraint on the Z symmetry there, maybe X symmetry there. Maybe that's good enough for now. Okay. Let's go ahead and export this to Nastran now and call it contact. Now this will take a little bit longer, right? Because not only does it have to mesh, but it also has to think about exporting the contact region. And the way contact works in the Nastran decks is it creates regions. It creates 2 different regions. The first region is, and this is the old one, so we'll kill that one. And we'll bring the editor back. So this is the old one. We don't need this one. I may have killed it by mistake, so let's go ahead and find it. The Nastran. Not sure what it did, so let's do it one more time. I think I just had too many things open. File, export to Nastran editor. Oh, it's there. It's a webinar, Nastran contact.nas. Okay, so let's go ahead and open that Nastran. So I'm better off at this point just creating it again. File, export, Nastran, contact.nas. Let's call it contact-2nas. I have too many versions of Simulation Mechanical installed on my machine, so the warning message we saw a moment ago was referring to that issue. I have 2015, 2014, even versions of 2017, so it didn't know which version to open it with. So here we go. We created this contact file, contact-2.nas, and now you're going to see something slightly different. Yes, we do have the contact generate card like before, which I'll go ahead and comment out again because we don't need it in this instance. Because instead of using the solver generated contacts, we're actually telling the software to create what we call BS-COMPs. And BS-COMP, if you press F1, is the surface contact parameter. So this is basically controlling how the contact between two segments, and those are called segment, BS segment, and you have two of them. This is the first one, and then there's a second one over there, and they are either a master or a slave type of segment. And how they behave is controlled with the next 2 or 3 lines of code. And if we don't have information in any of these lines, it could be just a single line of code as well. So when we look at this, we have a single line by default in our export mechanism. And depending on whether you have 2016 installed or 2016 with the App Store app, we will export it slightly differently. I don't have the App Store version now, so I get this export with 1e to the -7 tagged on to the end. And I just want to highlight what we're looking at here. So this, in its easiest form, is explaining to us that there's going to be contact between two segments, segment number 1 and segment number 2. And the number 1 here is the slave, and the number 2 is the master. And this number right here, and it's kind of hard to identify those, so let's go ahead and add some markers so we can see those a little bit easier. And this is a narrow field, and let's insert narrow helpers as well. So this field, which is field number 8, that gives us the 2, is this 8 right here, and that's this p-type. And p-type gives us the type of contact. So Nastran allows us to set up 10 different types of contact between two objects. And in the case of Simulation Mechanical, those objects are surfaces. So I can set up 10 different types of surface contact. And it could be an unsymmetric or a symmetric version of general contact. So the term general refers to the Simulation Mechanical's surface. It could be welded contact, and in the case of Simulation Mechanical, this is welded or bonded. It could allow us to do sliding contact, could allow us to do rough contact, and it would allow us to even create contact between objects that are separated with an offset. Okay? And there's one more field that's really important to us, is this max AD, which is field 9, which is right here. And we have a little comment above it, and you can read this on your own time. But whenever you're defining contact between two objects, Nastran has the capability to, like I said, define contact between objects that have an unmatched mesh. And because there's an unmatched mesh, it needs a certain tolerance of basically a lookup tolerance of the things that are within a certain range. And in this case, we are really truly touching these two parts. So we don't need a very, very large tolerance. But in Simulation Mechanical, we didn't have the user interface to control that tolerance field, so we just default exported something, a large number, and And then when we looked into it a little bit more, we realized that large tolerance is actually not a good idea. So if you download the app, Simulation Mechanical Supplemental Results app from the App Store, this actually gets written out differently. And by default, we actually leave it blank so that the solver calculates the necessary tolerance. So if I solve this, now I am able to solve an analysis where two parts in static stress, in two parts that are in static stress with an unmatched mesh can behave as if they're in surface contact, which is something that the simulation mechanical solvers by default cannot do for static stress. So that's another benefit, is ability to solve types of physics and types of contact that SimMech cannot do by getting into a Nastran type solving. So I'm not going to solve this, but I just wanted to highlight that there are many different types of contact you can control, and those are the p-types. You can control contact between objects that are separated, and you can type in a tolerance here manually to control that. And you can control whether you want a symmetric or an unsymmetric version. And of course, the symmetric is what we're all used to because Simulation Mechanical always does symmetric contact, meaning part 1 can touch part 2 as well as part 2 can touch part 1. But the unsymmetric solves much faster and relies on a master and slave relationship between the two objects. So that is it for my demonstration of the contact types and parameters. And I will go down to my conclusion slide. So what did we cover in today's webinar? We covered the ability to export your setup from Simulation Mechanical to Nastran Editor for a select set of analysis types. We covered the deck structure, and we covered pressing F1 on the type of cards that we don't know much about. Right? We click on get our cursor on top of one of those blue cards and press F1 and read more about what each card is in a Nastran deck. And then we talked about, once we have the results, the FNO file from a Nastran editor run, we covered merging those FNO files back into Simulation Mechanical to do post-processing on our results. And we covered how our results that we get from Nastran runs, if we edited the deck, will be different than our setup in Simulation Mechanical, and therefore we have to be very careful with our reporting. And that is the end of my, oh, there's a quick bug in my slide deck. This link is incorrect.
So Sualp, we do have maybe a minute or two here left in the hour presentation. So I'm going to go ahead and launch one of our last slides here, or poll questions here.
Great.
Related to next generation simulation beta testing. You know, we'd like to know if you're interested in learning more about some of the next gen simulation products that we're currently beta testing right now as Project Arrow. So feel free to leave your input there. We did have one question here, and I think we've got enough time to answer it from Gonzalo. And he said, are you inferring that the Nastran solver is many times faster than the simulation mechanical solver? And I think the question is, in some instances, it is, right? Yeah.
So the example I touched on earlier with the load cases, by definition, you can get to the results faster. I didn't necessarily mean the solver is faster. I meant to say that because we cannot set up a multi-load case analysis for differing gravity magnitudes and directions in Simulation Mechanical, you have to do it in two different design scenarios, or you know, 2 or more. So let's say 5 design scenarios. Solving 5 design scenarios is, by definition, more expensive, more time-consuming than solving a single design scenario with multiple load cases. For the types of things you can create multiple load cases in Simulation Mechanical, the solve times will be similar, regardless of whether you solve using SimMech solvers or Nastran solvers. But because Simulation Mechanical solvers cannot handle differing magnitudes and differing directions for for gravity in different load cases, it pushes you into a multi-design scenario type of an application. And therefore, solving that same setup will take you less time in Nastran compared to solving in Simulation Mechanical for large models. Does that answer the question, Andrew?
I think so, yeah.
Okay.
So we're actually out of time here, so at the top of the hour. So I appreciate everyone for joining us today. We'll go ahead and get this presentation posted on YouTube within the next couple days. And if you have any further questions, certainly feel free to post on the Simulation Mechanical forum. The support team's active on there as well. Or if you have, subscription, you can always log a technical support case if you're looking for help, maybe setting up your analysis to run with Nastran. Thanks again, Sualp, for presenting today, and thanks everyone for attending. I hope you have a great day.